This type of integration question I like to call integration by recognition. The questions are usually split up into two parts. The first part asks us to find the derivative of something, which is shown in part A, and part B asks us to evaluate some sort of integral. Now, all the time with these questions, the integral we can't evaluate with the current rules that we know. That's the point of part A. So part A should lead us into part B and give us some clue about what to do. So let's look at part A first and evaluate the derivative of x times log e x. We should recall from differentiation that we can use the product rule for this question. So what I do is I write our equation, x log e x, as u multiplied by v. So u is equal to x, v is equal to log base e of x. U dashed, the derivative of u is just 1, v dash is equal to 1 over x. So therefore I can apply the product rule to get dy dx is equal to u v dash plus v u dashed. So u v dashed and v u dashed I just get from this table that I've created on the right hand side here. So u times v dash would just be x multiplied by 1 over x plus v times u dashed, that'll just be 1 multiplied by log base e of x. So x cancels out with the 1 over x, so I'm just left with 1, then I plus log e of x. So therefore, the derivative of x log e x is equal to 1 plus log e of x. Sweet. Now, part B asks us to evaluate some sort of integral. Now, you might be thinking, how does this integral relate to the previous question? What we have to recall is that integrals are the opposite of derivatives. So for example, if I just found in the previous question that the derivative of x log e x is equal to 1 plus log e of x, I can rewrite this as an integral. What I just do is I swap around my two equations. So I can say the integral of 1 plus log e of x dx is equal to x log e of x plus c. Don't forget the plus c because we're integrating. All I've done in this situation is I've moved this to here and I've integrated it to get the original equation back like that. So that's from the previous part A. And the reason why I know how to do that is because the question has hence in it. A lot of people skip over this word, but it's actually really important in understanding how to do this question. Hence implies that you have to use a result from a previous question to help us answer the current question. So in this case, we had to use the result that the derivative of x log e x is equal to 1 plus log e of x. So now I get this line of working out here, and this helps me get the integral of log e of x. What I do is I split up my integral into two separate parts. I could say the integral of 1 dx is separate from the integral of log e of x dx. All I've done is I've just split that left-hand integral into two separate parts. Now the reason for that is because I want log e of x by itself as an integral. The right-hand side stays the same. Sweet. Now to get the integral of log e x by itself, all I do is I just move this integral to the left-hand side, from the left-hand side to the right-hand side by minusing it. So I say the integral of log e of x dx is equal to x log e x minus the integral of 1 dx. Now a lot of people just do minus 1 here. However, that's not quite correct. We actually have to find the integral of 1, which we should recognize as just x. So it'll be x log e of x minus x plus c. Put the plus c here as well. Sweet. So now I know the integral of log e of x in general, but the question asks us for a definite integral because we have to substitute in the 1 and 2 bounds. So once I know my general antiderivative, I could just substitute 1 and 2 into that equation to find my definite integral. So therefore, the integral from 1 to 2 of log e of x dx is equal to that same expression, except just substitute in the bounds. Sweet. So now let's evaluate this. 2 multiplied by log e of 2 minus 2, and then minus 1 times log e of 1. See, 1 times makes no difference. Minus 1. 2 log e of 2 minus 2. Log e of 1 is 0, so it ends up being minus negative 1, which becomes plus 1. Minus 2 plus 1 is just minus 1 there. 2 log e of 2, I could keep it like that, but I could also write it as log e4 if I wish. Just log e of 2 squared, bringing this 2 up to the power using our log rule. So therefore, the integral of log e of x from 1 to 2 is equal to log e of 4 minus 1. And again, we use integration by recognition. We use the fact that the derivative of x log e x is equal to 1 plus log e of x. We swapped around the derivative to make it into an integral form, and we separated the integral to get the integral of log e x by itself.